Hi, I'm William, reporting for the Fun Robotics Network. I'm here at the Southern Cross Regional with Team 6510 Pymble Pride. They have an incredible robot that can do all levels, learn about their awesome climber, their innovative elevator, and how they pick up and their strategy, all on behind the bumper. So yeah, getting yourself with the season, what was your strategies for that?
Yeah, we had a big kickoff day where the whole team kind of came together and we calculated all the points. So we calculated robots which we thought would be high scoring and ranked highly in competitions. We also decided that we really wanted to have a lot of ranking points. We wanted to be a robot that could do the ranking points ourselves and not have to rely on other robots. So for that we have our own deep climb, and we can also score L4 through to trough ourselves using the ground intake for trough.
For the ground intake, we started with a few prototypes where we wanted to be able to pass through from the ground, grabbing it from the ground and then putting it into the outtake. We achieved this when we had Omni wheels and mechanism wheels on these intaking wheels. And we also had a motor that, rather than having the wheels in the direction currently, they were perpendicular, which allowed us to then shoot it into the outtake. However, we found that with our current robot, we would be prioritizing L4 more than we would be prioritizing L1, and hence we focused in on having something that just grabs it from the ground and can score it into L1. And hence for this version of the ground intake, we decided to go with something that didn't have the mechanism wheels, didn't have the Omni wheels, and instead just allowed us to pick it off the ground and score it into L1. Yeah. Do you want to demonstrate it? Yeah, so that's practically how it works. Okay, do I outscore it? Okay. Switch out. There we go. Cool.
So moving from your ground intake, how does your overall human player intake work, and how does that end up scoring into the other three levels?
So we wanted to think beyond regionals, thinking past it for our next competitions. We decided that there might not be a lot of coral on the floor, and we would waste time trying to pick it up. Like, it would be hard to see, we might have problems with the ground intake, which is why we decided to keep the robot really as simple as possible and use a single mechanism to intake and outtake, which is our outtake here. It's on an arm, so it's basically a lift and then an arm, and this arm can help us reach L4 through to L1. The wheels are used to keep it in place, and the guides have a flanged opening, which means that we have more freedom when intaking from the human player source. We also use a limelight for automatically lining up with one of the little indents of the coral station, so we can intake really reliably and efficiently. We have two can ranges, which can be used by our coders to detect when the coral is intaken and then intake it even more so it doesn't fall out. We use an X44 motor because we've decided that the outtake needs to be as light as possible. In order to make it as reliable as it is right now, we need it to be super light. So we use an X44 motor as well as printed guides with a low infill and spaces, and just reducing the plate thickness as much as possible with this lightning.
So that's a really cool way of picking it up. How does it overall move into it? I see that there's this pulley system that allows for you to move the arm to get that articulation to pick up from the human player. How does it overall work?
So basically the entire pulley and arm system is supported by the gearbox down here. And it basically has like a 3-stage max planetary gearbox. Oh, 1-stage max planetary gearbox down there. That's 1:9 ratio. And inside there's like 4 different gears that's connected to the pulley that supports the arm and the pivot point up here. And a challenge we had when designing the gearbox is to avoid as many backlash as possible when we're moving the outtake and intake, because during the comp you want the most precise measurements as possible, so you don't want any backlash. So when designing the gearbox, we were considering like the center distance between each gear, and we minimized we first used the gearbox center distance ratio calculator, and then we minimized the center distance with a specific number that reduced a lot of backlash and made the gearbox and the arm have very less backlash overall.
Happy, do you want to showcase the
So, would you like to showcase the scoring overall?
So that's how we intake from the coral station. That's the ground intake. We're going to show the positions. Okay, so this is our L4 position. It is higher than the L4 by a little bit, so we have a lot of freedom when outtaking. The guides being wide as well helps with getting it on the L4 stick, the L4 stick with as little error as possible. Now if we go to L3, this is our L3 position. This is probably the easiest position for our drivers because of the coral sticking out a lot. It's uses limelight to line up also, and it's a really reliable position for us. Go to L2. So with our L2 position, we kind of shoot the coral on a little bit to the stick. We found it works really well. If we have enough momentum, it swings straight over and on without difficulties. And then that's our home position.
I see that you also have this cool climber over here. Would you be able to explain how you guys do the deep climb?
So our climber is also supported by a 3-stage max planetary gearbox, and inside there's also 2 gears that supports the sprocket on the outside of the climber, and that makes the climber really, really strong. And that's because after prototyping, we've noticed that the climber doesn't hold the entire robot up for long enough. So instead of before, it only had 3 max planetary gearbox, and we've added the gears inside to make sure it climbs really efficiently. And before, the arm on the climber used to be inside the robot, and we had to lift the entire outtake structure to move the arm of the climber out and to be able to climb. But we've made 2 holes in the plates of the climber, so then the arm can rest in an outside position, and we travel less distance when we extrude out and try to climb.
One of the things I've noticed about this robot is the awesome billet chassis. Why did you choose that, and why did you choose that?
So this season we wanted to experiment with a lot of the materials that we have, and in that sense you can see that we're using carbon fiber and 7075 aluminium on a lot of our mechanisms, such as the ground intake, the lift, the arm, practically everywhere, because this allows us to lighten as much as possible and control our center of gravity. Hence, leading on to why we decided to do the billet this season, is with the billet we have the adaptability of lightening wherever we would like to, and that allows us to reduce lower center of gravity, put the mechanisms wherever we want easily, meaning we don't have to rely on having tubes and gussets and to hold up our entire mechanisms. And a lot of the positioning of our mechanisms are easily removable. Basically, if you have a look under the billet, you would be able to see that there's only like 8 bolts holding in one mechanism. You remove those and you can freely move the mechanism out. And then the last reason why we moved onto billet is last year we had a really horrible season in terms of bumpers. Our bumpers kept on being demolished, and with us now having such a strong billet chassis, the surface area touching the bumpers increases, and also it's just indestructible practically. So we don't have to suffer with having a bent chassis and then consequently having an entirely off robot by everything else being bent. But yeah, that's practically why.
Thank you so much for sharing this overall really cool robot design. It's just been a great robot to see here. Thank you again, and have a great rest of the competition.